projects. In this video, we are going to explain about a project titled Air Quality Prediction using ML. So now coming to the introduction part. The quality of air is a vital element of environmental well-being, influencing both individual health and the resilience of ecosystems. As apprehensions rise about escalating pollution, there is an expanding requirement for proficient tools to anticipate and control air quality. In this context, the utilization of machine learning has arisen as a potent and inventive remedy. Through the application of sophisticated algorithms and data analytics, machine learning techniques have the capacity to scrutinize extensive data sets including diverse environmental factors, enabling the prediction of air quality levels. So now coming to the objective part for this project is to construct precise and dependable models that can anticipate forthcoming air quality levels using both historical and real-time data. Through the application of sophisticated ML algorithms, the objective is to establish predictive models capable of examining various environmental factors like particulate matter, ozone, and nitrogen dioxide, in addition to considering meteorological conditions, traffic trends, and industrial operations. These models strive to unveil intricate patterns and correlations within extensive datasets, thereby enhancing our comprehension of the intricate dynamics influencing air quality. So now coming to the requirements part, here we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required. Processor i5 and above. Minimum 8 GB of RAM is required. Hard disk 20 GB and above. Coming to the software requirements part, in Anaconda 3 is required. Visual Studio Community version is required. So now coming to the Flow project. Here first we have importing the packages. In this module, necessary libraries and packages which are NumPy, Pandas for data manipulation, sklearn to facilitate machine learning, and Matplotlib and Seaborn for visualization are important. Second, here we have exploring the data set. So here in this air quality data, and another here we have air pollution data and self-created data. So in air quality data, you explore and analyze the air quality data set which likely contains information related to air quality parameters. Second, here we have air pollution data. Similar to the air quality data, you analyze the air pollution data set which may include factors contributing to the air pollution. Next, here we have self-created data. This could be additional data that you have generated or collected for your project. Then here we have next as data processing. In this we have Pandas data frame. You use Pandas to manipulate and clean the data, creating data frames for easy analysis. The next here we have Keras data frame. Keras might be used for specific data processing tasks related to deep learning. Then we have dropping unwanted column, removing unnecessary columns to streamline the data. Next here we have visualization using Seaborn and Matplotlib, exploring data visually using Seaborn and Matplotlib to gain insights and identify patterns. The next here we have feature selection, identifying and selecting the most relevant features for your analysis. Then we have splitting the data to train and test for deep learning, dividing the dataset into training and testing sets for model evaluation. And then here next we have building the model. Air quality, various models are considered: linear regression, random forest, elastic net, decision tree, voting regressor, that is combining LR and RF, CNN which stands for convolutional neural network, RN which stands for recurrent neural network. Next here we have air pollution, forecasting models including LSTM which stands for long short term memory, GRU gated recurrent unit, and the combination of CNN and LSTM. The next here we have training and building the model, training the selected models using the training data set. Next we have Flask framework with SQLite for sign up and sign in, building a web application using Flask, incorporating a SQLite database for user authentication, that is sign up and sign in. Then next we have importing the packages. It is similar to the previous step where we have to import the packages like NumPy, Pandas and Matplotlib. The next here we have user gives input as feature values. User provides input presumably for making the predictions. Then we have the given input is pre-processed for prediction, processing user input to prepare it for input into the trained models. Then next we have trained model is used for prediction, utilizing the pre-trained models to make predictions based on the user input. Then next here we have loading the feed data from API for forecasting the given states, fetching real-time or additional data from an API to enhance predictions, particularly for forecasting. And the last one here we have final outcome is displayed through front end, displaying the model's predictions and other relevant information on the front end of the web application. So now coming to the execution part. To execute the project, first we need to open the code folder. So here you can see that there is a folder which is named as template. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc. which represent different pages of the website. Then we have a folder which is named as static. This folder consists of files related to CSS, JavaScript and Bootstrap files. The next here we have the folder which is named as data. This folder contains of the data set which is used in this project. Next here we have .ipynb file, which is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows the users to write and execute code in individual cells, making it a popular choice for data finds. The next here we have app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database and generating dynamic content to be rendered in the HTML templates. So now just click over here and copy the path. Open the Anaconda prompt. Type the cd command followed by a space and paste the path over here and now hit the enter button. Now type python app.py and now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address and port 5000 unless configured differently. So here you can see that the link has been posted over here. Just copy this link and paste it into any of the browser. Here I am using Chrome. So just paste the link over here and now hit the enter button. So here you can see that this is our home page for the air quality index prediction. So just enter the average temperature in degrees Celsius, maximum temperature as 21, minimum temperature as 2, atmospheric pressure at sea level is this, average relative humidity, average visibility 12, average wind speed is 2, maximum sustained wind speed is 2. And now click on predict button. So here you can see that it is showing the prediction that predicted value for particulate matter is 2.5 is minus 225.101. It is showing as good. So depending upon the parameters you are providing over there, it is showing the prediction as about the whether So here you can see that there is a button for forecasting. Just click on it. And here you can see that it is showing about the air pollution forecasting. Air quality indices of major Canadian cities and New Delhi. And here again you can see that there is a button for Chennai. Just click on it and here you can see the time for the Chennai. For Toronto, here you can see about this. Similarly for the Calgary, Vancouver, this is for about the New Delhi. And here you can see by clicking on the forecast, it is showing the graph for this. Here blue line is showing the average, red here is for maximum, and here or yellow is for minimum. By clicking on the about button, you can see about the air pollution forecasting over here as it is written over there. Let's click on the prediction button and here you can see that there is a button for about. Let's click on it. So this is all about the air quality index prediction. So now coming back to the conclusion part. In summary, integrating machine learning into air quality prediction signifies a substantial advancement in tackling the urgent issues presented by air pollution. The creation and utilization of machine learning models presented a potent solution for precisely predicting air quality levels, surpassing the constraints of conventional approaches. By exploring extensive datasets that include diverse environmental factors, these models can unveil complex patterns in relationships, providing a nuanced comprehension of the dynamics that impact air quality. So here we have completed with our project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.